I'm here to give you a brief review on trigonometry, and I'm going to fill out this table, and I'm going to do it in the laziest way possible. So here's the first thing, is I have to know what the trig functions mean. So if this is a horrible unit circle, and it is a horrible unit circle, this should be 1, 1, negative 1, negative 1. Here's what sine and cosine mean. If I walk along this far, if this is x, here's what this point right here, this is the point, say a comma b. This is really equal to cosine x. The x coordinate there is cosine x sine x. So in other words, if you had a little unit circle here, and you went along at, say, I don't know, 0.9 something, that makes it work out, then cosine of this x right here, where you walk that far along the track, is going to equal 0.9. So it's as easy as just looking at the coordinates. So, and that allows us to fill out a good portion of the table, right? So I can just look at coordinates. Notice right here, this is the point 1, 0. So cosine, so I've walked 0 units around the track. If I walk 0 units around the track, cosine's 1 and sine is 0. So if I walk 0 units around the track, cosine's 1 and sine is 0. This point right here is also very easy, is the point 0, 1. And so pi over 2 is the angle. And so sine of pi over 2 is 1 and cosine is 0. Switch. Similarly here, pi, it's nice and easy, that's negative 1, 0. So cosine's negative 1 there. You get 0. And similarly down here, it's nice and easy to get, and you get negative 1 comma 0. So this is the idea that I use to get all my sines, right? So if I have a point that's right here, I don't know what cosine, and sine are exactly, but I know that both are negative right here, so I know that cosine's negative and sine's negative. So by using reference angles, I can figure out what, cosine of 7 pi over 6. I can figure out what that is. I know it's going to be negative because the x value is negative here. Okay, so then a little bit more. If I have an equilateral triangle, I know that all the angles are 60 degrees, which is pi over 3, pi over 3, pi over 3. And let's make an equilateral triangle of length 1. And then I'm just going to split it into 2 to get a right triangle. This has angle 60 degrees, which is pi over 3. This has half of 60, which is pi over 6. And I know that that length is 1 and that length is 2. And by the Pythagorean theorem, I get the square root of 1 squared minus 1/2 squared equals square root of 3 over 2. So now, if I want, I can use SOHCAHTOA to figure out that for pi over 6, the sine is the opposite over adjacent. So pi over 6, the opposite over adjacent is just 1/2. And then the cosine is adjacent over hypotenuse, which is just square root of 3 over 2. And same reasoning with cosine, just kind of flips them around. Square root of 3 over 2 and 1/2. And next, I can use an equilateral right triangle. I'll try to draw it as such. That has an angle 45, 45, 90, which is pi over 4, pi over 4. 1, 1. Oh, and then using the Pythagorean theorem, I'm going to get square root of 2. So cosine of pi over 4 is 1 over square root of 2, which you sometimes reduce as 2 over square root of 2. And similarly over here. So that's how I can fill in this table. And then the rest of the table is very easy to fill in. This is just sine over cosine. This is just 1 over tangent. That's just 1 over cosine. And that's just 1 over sine. And I have all the values here. So I can figure out what they are really quickly. And again, I can use reference angles to figure out any other weird value like 7 pi over 6. And I use this idea here to figure out what the sine is. That's all I know about trigonometry.